We are going to skip the main part of example 4 and just look at the try it together. Looking at the parallelogram shown, what is the value of A? Well, we know that those two angles are supplementary, so we would take the 8A minus 5 plus the A plus 5, and that needs to add up to 180 degrees. So that's 9A, and then minus 5 and plus 5 cancel each other out, so equals 180. And we know that A, if we divide both sides by 9, comes out to be 20. So what are the measures of G, H, J, and K? Well, if I plug back in the 20 plus 5, then H, measure of angle H, is 25. That means that the measure of angle K should also be 25. And then plugging it in for the 8 times 20 minus 5. 8 times 20 is 160, minus 5 is 155. So the measure of angle G equals 155 degrees, and the measure of angle J is also 155 degrees. And you can check that 25 and 155 add together to equal 180, and they are supplementary. Now let's look at example 5. Make a conjecture about the diagonals of a parallelogram and write a proof of the conjecture. Well, the conjecture we're going to make is that those diagonals are bisecting each other. So the first thing that we know is that it is a parallelogram. That means that the opposite sides are parallel and congruent. So we know that those pieces are parallel and they're also congruent. We also know that BD is a transversal of those two parallel lines, meaning that angle 2 and angle 3 are alternate interior angles and congruent. So let's just say angle 2 is congruent to angle 3 by alternate interior angles theorem. Kind of do a little bit of an informal proof here. Then we can look at this transversal and discover that angles 1 and 4 are also congruent by the alternate interior angles theorem. So we'll give those 2 marks. Since we know that these opposite sides are congruent, and we know that those angles are congruent, we have that triangle ABQ is congruent to triangle CDQ. Make sure our letters are in the right order. And that is by angle side angle congruency theorem. Okay, so now we know that those triangles are congruent. We can see that their parts are congruent. So this part and this part would be congruent. And this part And this part would be congruent. So we have proven that the diagonals bisect each other. Go ahead and pause your video and do the try it and then come back. SK is 1/2 of SU, and SU is the whole length. And so SK is half of 35, and half of 35 is 17.5. So SK equals 17.5, and RT is the whole length, and we're given that half of it is 19, so we say that RT equals 2 of KT. So 2 times 19 equals 38. So our diagonals of a parallelogram theorem states that if a quadrilateral is a parallelogram, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So given the diagonals right here, let's mark this midpoint as, let's call it A. That means that XA is congruent to ZA, and WA is congruent to YA.